We'll be talking about the 9-point circle, and here is the theorem. Consider a triangle ABC with orthocenter H. Let D, E, and F be the feet of the altitudes. Let I, J, and K be the midpoints of the sides, and let L, M, and N be the midpoints of AH, BH, and CH respectively. These 9 points are concyclic in the 9-point circle. So we have the triangle ABC with D, E, and F being the feet of the altitudes. And then we have I, J, and K being the midpoints of each leg of the triangle. And then lastly, we have L, M, and N, which are the midpoints from the vertices to the orthocenter. So now we're going to prove why these points lie on this circle. So we're going to start off by looking at triangle ABH, as it's written right here. So we can see that K is the midpoint of AB and M is the midpoint of BH. I already connected the 2 points to make a segment. So the segment is KM. And we can see, since K and M are both midpoints, the line segment KM is the midline of the triangle ABH. So we can pull a few facts from this, if you can say. So we can see that KM is parallel to AH, since it is the midline of the triangle, and also KM equals 1/2 AH. KM is half of AH. So now let's look at another triangle. Let's look at triangle ACH. So looking at ACH, we see that J is the midpoint of AC, and N is the midpoint of HC. So let's connect these 2 points to make a segment. So here we have the segment JN. Similarly, it is the midline of the triangle. So since it's the midline, segment JN is parallel to AH, and JN is also equal to half of AH. So we can connect a few things here. We can see that KM is parallel to AH, and it is parallel to AH, but it is also parallel to JN. And KM is equal to JN. So now let's look at triangle HBC. So we can see that M is the midpoint from BH and N is the midpoint of HC. So let's connect these 2 points. So then, since these 2 are midpoints, MN is the midline of the triangle. So MN is parallel to BC, and MN is equivalent to half of BC. And then we're going to look at one more triangle, triangle ABC. So we have K as the midpoint of AB and J the midpoint of AC. So we can connect these 2. So KJ is now the midline of triangle ABC. So we can write that KJ is parallel to BC, and KJ is equivalent to half of BC. And here we can conclude that MN is parallel to KJ, and MN is also equivalent to KJ. That if we extend these segments, they are perpendicular. KM is perpendicular to BC, and JN is perpendicular to BC, since KM and JN are parallel to AD, and AD is perpendicular to BC. We can also see that KJ and MN are perpendicular to AD. So since KM and JN are parallel and equal, as well as MN and KJ being parallel and equivalent, we can conclude that KJMN is a rectangle. Knowing that rectangles are cyclic, we can see that KJNM is concyclic, meaning that the center of the circle is the midpoint of the diagonal. So let's draw the diagonal. So now we have the center of our circle, which is the intersection of our diagonals of the rectangle. Mark this point P. So now I'm going to continue with another few triangles. So let's start off by looking at the triangle ABH. So we have triangle ABH. We see that K is the midpoint of AB and L is the midpoint of AH. So if we connect these two to make a line segment, we have another midline. So KL is parallel to BH, and KL is also equivalent to half of BH. So looking at another triangle, HBC, we see that N is the midpoint of HC, and I is the midpoint of BC. So we have IN is parallel to BH, because when we connect these two to make a line segment, it is the midline of triangle HBC. So IN is also equivalent to half of BH. So through these notes, we can see that KL is parallel to BH. It is also parallel to IN. And KL is also equivalent to IN. So let's look at triangle ACH now. So L is the midpoint of AH, and N is the midpoint of HC. So we can connect these two points to make a line segment. Since these both are midpoints of the triangle, the line segment LN is now the midline. So LN is parallel to AC, and LN is also equivalent to half of AC. And our last triangle looking at is ABC, where K is the midpoint of AB and I is the midpoint of BC. We can connect these 2 points. So KI is now the midline of ABC. So where KI is parallel to AC, and KI is also equivalent to half of AC. So we can conclude that LN is parallel to KI, and LN is equivalent to KI. Just like the last rectangle we made, we can see that these segments are equal and equivalent. And they form another rectangle. And as we know, the rectangles are concyclic. And the center of the circle would be the intersection of the diagonals. So let's draw the diagonals of this rectangle. So we have that diagonal LI, and let's just write down our rectangle. And we can see that rectangle KL and I share a common diagonal with KJ and M. So since they share a common diagonal, the diameter is the same for the circle, meaning they lie on the same circle. So we proved that these 6 points all lie on the 9-point circle. Lastly, we just need to prove that the feet of our altitudes lie on our 9-point circle. So let's look at point D. So we know that AD is perpendicular to BC with D lying on BC. But let's look at the triangle LDI. When looking at the triangle, we see that LI is the hypotenuse of the triangle, but LI is also the diagonal of rectangle KL and I, and we already found that L and I lie on the circle. So since angle LDI is 90 degrees, and the hypotenuse of this triangle is also the diameter of the circle, D must lie on the circle. So using the same logic, we look at point E, and we know that BE is perpendicular to AC with E lying on AC. So let's look at triangle MEJ. When looking at this triangle, we see that the hypotenuse is also the diameter, not the diameter, is the diagonal of triangle K, L, and M. So since we found that this triangle, these points lie on the circle, and MJ is the diameter of the circle, E must lie on the circle. And lastly, we have point F. So now let's look. We know that point F is CF is perpendicular to AB, F lying on AB. And let's take a look at triangle KFN. So we see that the hypotenuse is also the diagonal of the rectangle KJNM. So this point F must also lie on the circle. So we've proven all the points. Let me just sketch this out. As we saw in our first picture, the 9-point circle, now we have proved that all 9 points lie on the 9-point circle. So that is all. Thank you.